Hello everyone, welcome to 𝐂𝐤𝐬𝐿. Good afternoon. How are you all? So welcome to 𝐂𝐤𝐿, welcome to compiler design. So today also we are discussing about compiler design topic. So before going to start the session, in last two lessons we discussed something about compiler design basic concepts. So let us recap some previous concepts, then we will continue today's concepts. Okay. So what we have completed in the previous classes, let us go to the recap. Today actually the second chapter of the compiler, our top-down parser. Actually in today's class we are going to discuss about basics of top-down parsing. What is required? What is the prerequisite for top-down parsing? Okay. Hi Pranjal, hi Astik. How are you all? Hello everyone, welcome to compiler design. I hope all of you attended previous last two lectures, right? So in previous two lectures, we discussed some basic concepts related to compiler design. So in the first lecture, we discussed about lexical analysis, what is the meaning of tokens and what type of lexical errors will be detected by the lexical analyzer of a compiler. So but the basics of compiler and some different phases designing. First phase designing lexical analysis, that is what discussed in the first lecture. So I think some of our friends are joining slowly by that time. Let us recap some of the concepts here. Right. So in the first lecture, we discussed about lexical analysis of a compiler. Lexical analysis phase of a compiler. And in this, what are the meanings of tokens? How tokens are produced? What is the meaning of a token? What is not a token, what is a valid token, what is the invalid token, everything we discussed in the first lecture. And then in the previous lecture, last lecture, we discussed about grammar, because to design next phase, syntax analysis or parser, syntax analysis also called as parser. So in order to discuss about this phase, we need some of the basics of concepts of grammar. Some concepts of grammar, some basics of grammar is required. That is what we discussed in the last class. Okay. So longest prefixes, that's what. So whenever while generating tokens, we discuss this terminology while generating tokens. Right. So today also we are going to discuss about something related to grammars. See some of the, I'll just revise in briefly in 1 or 2 minutes about grammar. Grammar is set of rules used to describe strings of a language. Grammar is formally defined with 4 tuple. Grammar is a 4 tuple notation. Formally we are defining grammar with 4 tuples: NTPS, non-terminals, terminals, production, starting symbol. So NTPS notation is used in order to describe about a grammar of a language. Okay. So whenever grammars are given, see, for every design of every compiler, we should provide some grammars. See, whenever we are designing a compiler, so there is a specification of rules of that language that will be represented by using grammars. That means whenever we are developing compilers, designing grammars is the minimum requirement. So especially mainly whenever you are designing syntax analysis phase, first thing we have to design grammars. There are two things. Yesterday I told you. Let us see the syntax analysis phase once. We have seen this in the last class. Now we are in the designing of this part. How to design this part? To design this program, second one, syntax analysis. Syntax analysis takes tokens as well as grammars, especially context-free grammars. Tokens and context-free grammars as input and verifies tokens are generated or not. Tokens are generated, parse tree is produced. Tokens are not generated, syntax error is produced. Syntax error is produced. This is what the aim of this program. The program syntax analysis or parser, what it is doing is, it is taking tokens and context free grammars as input, and these are generated from, tokens generated from grammars or not. Tokens are according to the grammar rules or not. This verification is done. This grammars are nothing but syntax. What is syntax here? Grammar is called as syntax. That's why this phase is also called as syntax analysis. And token membership is verifying. That membership verification is parsing. That's why this phase also called as parser or parsing phase. Right. To design this, we want two things. One is grammar designing. Grammar construction. Second one is parsing algorithms. Parsing algorithms. So what is the use of grammar that we discussed in the last class? Today also something related to grammar and some concepts of parsing we are discussing in the today's lecture. Right. So what we are going to discuss in today's lecture is, we are discussing something about grammar. And there is some information. In the last class we discussed about ambiguous grammars also. So in today's class, first set information of a grammar, how to compute a first set from grammar, and how to compute follow set. From grammar. So this first and follow are very important concepts of parsing. So whenever we are doing any parsing, whenever we are performing any parsing, first set and follow set information is very much required. Whether it may be a top-down parser or bottom-up parser. Okay. Parsers are mainly two types. I will show you the parser diagram as well. To design parser, we have these things. So LR0 parsers, SLR1 parsers, LALR, CLR. Basically, there are two types of parsers: top-down parser, bottom-up parser. In top-down, we have these categories. In top-down, we have different categories, and in bottom-up, these are top-down parsers, these are bottom-up parsers. Whatever may be the parser, parser means our syntax analyzer to design this. So for top-down parser as well as bottom-up parser, for both of this, we want to find some information called as first set, follow set from grammar. All these are some of the basic information we need to analyze from grammars. Yesterday we analyzed something from grammars in our yesterday's class. In our yesterday's class, we analyzed ambiguity from grammars. We verified what is grammar. We have studied what is a grammar, what is parse trace and all this. Then ambiguity verification we did from grammar. Like this, to construct parsers, we need to analyze some more information from grammars called as first set and follow set information. Okay, right. So in today's class also, we are discussing about grammar only, grammar some, but in a different way. Okay, right. So in the last class, what is grammar and what is derivation, what is leftmost derivation, what is rightmost derivation, what is derivation tree, and all these things we verified. Now in today's class, types of grammars. We are going to see types of grammars. Types of grammar. Especially there are four type of grammars here. There are four type of grammars called as type 0 grammar, type 0 grammar, type 1 grammar, type 2 grammar, type 0 grammar, type 1 grammar, type 2 grammar, type 3 grammar. There are other names. Actual names are like this. We'll say regular grammars. Other names for this is regular grammars, context free grammars, context sensitive grammar, unrestricted grammar. Okay. To design compilers, we'll use regular grammars. Regular grammars in the sense regular grammars, regular expressions, finite automata, all this comes under in this way. So we use regular grammars, we use context free grammars, we use context sensitive grammars. Still this part is required to develop a compiler. Yeah, it is Chomsky hierarchy, but to design compilers, these three type of grammars. To design our parser, syntax analyzer, we are using the second type of grammars called as context free grammars. Context free grammars. So their automata is there, but automata is nothing but a program here. Automata is theory of computation, theoretical concept. For every for the corresponding grammar, automata will be there in the form of program. Our program parsing, our syntax analyzer is pushdown automata. Okay. So in last class, we are saying about grammars. Especially to design a parser, we are dealing mainly with context free grammars will be used. How this context free grammars looks like? Context free grammar structure is left hand side only one noun terminal, right hand side alpha belongs to v plus t whole star. Any number of variables, any number of terminals. This can be anything. So left hand side one noun terminal, right hand side anything. This type of grammars we are dealing here at syntax analysis phase of a compiler. So whenever we want to design a parser or syntax analyzer, we are dealing with context free grammars. Okay. So this is the name of the grammars, right? Let us try to construct context free grammars for the given languages. Assume I have a language like this: a power n, b power n, c power m, n comma m greater than or equal to 1. This is called as context free language. I think you have idea about this. This language comes under a regular language or context free language. Whether this one comes under a regular language or context free language. I think you have some idea about identification of languages. Clearly this language is nothing but sorry. Clearly this language is a context free language. Whenever we have like this context free language, how to construct a grammar for this one? The grammar for this is, first for a power n, b power n, ab will take a middle recursion or ab. This is the grammar production for a power n, b power n. We can construct grammar production like this for a power n, b power n. Whenever it is c power m, take a non-terminal. This is c power m. This is for c power m. So at s, a followed by b. So this is what the grammar for this. Now this grammar is called as context free grammar. This is context free grammar. So these type of grammars generally used to design our syntax analysis phase of a compiler, right? In today's class, we are discussing about context free grammars, especially context free grammars. Context free grammar is nothing but Left hand side one non-terminal will be there. Right hand side any number of terminals, any number of non-terminals. These type of grammars generally called as context-free grammars. Okay. So we are dealing this type of grammars to design a syntax analyzer or to design a parser. So whenever you want to develop a parser or syntax analyzer, we require context-free grammars. Basic, normal, regular grammars are not sufficient to design this phase. Okay. And one more thing we want whenever we are dealing with this grammar is, whenever we are dealing with parser or top-down parser or bottom-up parser, actually, even if you want to design top-down parser, or if you want to develop bottom-up parser, so for both of these, we need to find the first set and follow set information. First set and follow set information. So like our ambiguity analysis, however, we did in the last class, today's class we will focus on how to retrieve first set and follow set information from the grammar. If once it is done, developing a top-down parser like LL1 parser, any top-down parser is very easy. So in today's class, we are discussing mainly on how to analyze first set information and follow set information from the given grammar productions. So this is what our today's lecture agenda. Right. Let us go for the first set. First set, follow set. Last class we learned about ambiguity. By using all this information collectively, we are going to design a parser from tomorrow onwards. Okay. So to design mainly to design top-down parser, this is a basic information which is required or to develop any. Right. What is first set here? From the given any given thing, so someone asking Muhammad Owaisi, please complete TOC. TOC is already there actually. In this English channel, we have a theory of computation which is completed. I think you have a playlist here. You can go through my TOC classes. My TOC lectures already available here. You can just go through those. What is context-free language, what is regular language, what is Turing machine, what is push-down automata, all these things I have explained, which are available in the same channel. You just go through those. If you want regarding anything information regarding theory of computation lectures. Right. First set. See, whenever we say first set of a non-terminal will gives us, first set of a non-terminal will gives us whichever the terminals available in the first position in the right hand side. So first set, when we are calculating first set for non-terminals, the first set of a non-terminal is nothing but first available terminal information we'll get. Okay. So first set generally we'll get for we'll calculate for non-terminals or some strings. Assume to compute first set information, these are some of the generalized rules. If you know these rules, it is very easy to identify, to calculate first set from grammar. So these are the rules. Here we have 4 rules. First one is first of any string ABC. The first of string ABC is nothing but first available symbol information, that is nothing but A. So that's why first of ABC is nothing but A. First of ABC is A. Next one, assume we have a grammar production like this, AX or BY. A gives AX or BY. If you have a production like this, then what is the first information? First of any non-terminal is nothing but that non-terminal right side available first terminal's information. Assume this non-terminal having how many productions capital A having here? The non-terminal capital A having how many productions? How many productions in the right hand side? So in the last class, in yesterday's class, we have identified about grammars, many terminologies. We have learned about grammars, number of productions and all this. Here non-terminal A having 2 productions. A is having 2 productions. One is this production this production. From every production, first available terminal we will catch. So if we go like this, can you tell me what is first of A? First of capital A. First of capital A is nothing but from this first available terminal information, that is A, from this first available terminal information, that is B. So the first of capital A is nothing but A comma B. A comma B. So whenever a non-terminal having, any non-terminal having productions like this, then first of this non-terminal capital A is nothing but A comma B. This is the information we'll get from this first set. Very good. Sometimes if a terminal available in the first positions, we'll feel it is very well and good. We'll get the information very easily. We'll feel very easy calculation of first set. But sometimes in the right side, in the first position, if non-terminal exists, then how to find first information? If any production, look at this third one. Second thing, I think it's clear. Now look at the third one. Third one is, in any production, capital A gives Bx. Capital A gives Bx. If you need to find first of capital A, then what is actual capital A? First of capital A is nothing but right side available terminal information we are calculating. But in the right side, we have capital B, where B does not produces epsilon. B cannot generate epsilon. Then first of capital A is nothing but first of capital B. So if a grammar having production like this, if any grammar production is A gives Bx, then first of capital A is nothing but first of capital B. Here B should not produce epsilon directly or indirectly. This is about third point. The fourth point is, assume B also produces epsilon. If B does not produce epsilon, that is the third point. Assume if B produces epsilon, that comes under our fourth point. So what is the fourth point here? The fourth point is very clear. If any production is like this, A to Bx, A gives Bx, B produces epsilon, then the rules are clearly written here. There is no confusions. It's very easy. Epsilon case is the main important case. So first set calculation is actually very easy. Only students where they generally confuse is, that is the place of epsilon. Whenever epsilons are there, we need to calculate them properly. Okay. So here A gives Bx, and B produces epsilon. Then first of A is nothing but first of B minus epsilon. First of B, we'll take first of B. Epsilon is there in this, that's why exclude that. Then union, again calculate wherever epsilon is there. If epsilon is there, for that next one first also we need to calculate. So take the first of B, all the elements of first of B minus epsilon, union, next symbol. If some epsilon is there here in the X also, then take all the elements, union, its next symbol. Like this we have to continue. This is the way. Okay. So if you continue in this way, it is very easy to compute first information. Like this, based on these four rules, we can compute first of every non-terminal for the given grammar productions. Okay. We'll take some examples. We'll try to compute first information from the given grammar productions. So what is the use of this first and follow? That you can understand very clearly while designing parsers. Whenever we are designing parser, we can understand very clearly what is the use of first information, follow information while doing parsing. Parsing tables, especially whenever we are doing parsing, whether it's top-down parsing like LL1 parsing, we have to construct parsing tables. So to construct tables, first information, follow information we'll use. That is a major thing here. So parsing tables are major thing for any parser, whether it may be top-down parser or bottom-up parser. If a parser has to run properly, parsing table should be available for that. Okay then. Through some examples, let us try to understand what is first and follow of this. Find first set for given grammar. We have one example here, one simple example. One grammar is given. We need to find first set for this grammar productions. Here three non-terminals are given. For these three non-terminals, we need to find first. So here we need to compute what is first of S, what is first of A, what is first of B. To compute first information, we have already taken rules. So students, all of you, please remember these 4 rules properly. If anybody want, just write down these rules somewhere. These are the fundamental things which are required to compute first information. So just I'm giving 1 minute time. Just write these rules somewhere. This is the basic thing which is required. Right. Now by using same thing, we are trying to analyze. Let me calculate from first of B. So here what is first of B? First of non-terminal B. First of B is nothing but right side available terminal information. Here we have two productions, from this B, from this C. So here no confusion, directly it is available. Next we need to compute first of A. Order can be anything. We can start from starting symbol. First I am calculating easily coming things. So I can easily analyze first of B as well as first of A. What is first of A? First of non-terminal A. Non-terminal A is also having two productions here. Two productions. So here from this right side first available terminal is A. From this first available terminal information is B. So first of capital A is nothing but A comma B. Similarly, what is first of capital S? First of capital S. First of capital S is nothing but, so S right side there is no terminal. Whenever terminal is not there, first of S is nothing but first of capital A. See the rule here, second rule, third rule. First of capital A is nothing but first of capital B. The same way, first of S is nothing but first of B. First of B. What is first of B? Which is already there, BC. So first of A it is, first of S is equal to first of A. Just a minute. First of S is right side available first symbol. First of A. First of A is nothing but, so AB. So that's all. So first of S is AB, first of A is AB, first of B is nothing but BC. So this is first information for every non-terminal of this grammar. In this grammar, for every non-terminal S, that is first of S we have computed. First of S we have computed, first of A, first of B. This is. Epsilons are not there. Whenever epsilons are not there, it is very easy to compute first set. Even epsilons there also, it's not difficult, easy only. But how to compute? But you have to compute carefully. Whenever epsilons are there, compute first set information very carefully. Okay, right. Let us go and compute first set information for some epsilon cases. This is one of the grammar. We need to compute First set information. First set of every non-term. See here, first of B. Let us compute easy things for easy things. Let us go from first of B. First of B is B. First of A. First of capital A. First of capital A is A epsilon. First of B is B. First of capital A epsilon. First of S. Here from here, see from here A, from here epsilon. This is first of capital S. First of capital S. For this terminal directly available. So no need to compute anything here. So it is nothing but A. Here epsilon is there directly. If it is directly there, replace. Whenever indirectly is there, the way of computation is different. We'll see one kind of example for that one also. Let us go for the one more example like this. Come to this. We have a grammar production. So here we need to compute first of B. What is first of B? First of B is B epsilon. From here B, from here epsilon. First of A, like first of B already computed. The same way, first of A. First of A right side. We have two productions. From here, first available terminal. So from here we'll get A. From here, epsilon, A epsilon. So first of A is A epsilon, first of B is B epsilon. Now first of S. First of S is very simple. See, fourth, this comes under the fourth rule from our previous rules, fourth rule. A to Bx, first of B minus epsilon, union first of X. So in the same way here, first of S is first of A. First of A is A epsilon. So we have to take minus epsilon. That means we have to take A. Whenever epsilon is there here, whenever epsilon is there, union, next one, first of B. First of B. Union first of B. What is first of B? B epsilon. Epsilon is there. Minus that, and again we have to take union. Just two things. Very simple. This rule is, fourth rule is, whenever B contains epsilon, minus then union. Minus union. This is the way we have to compute epsilon. First set in the epsilon case. So here, minus that epsilon, exclude that epsilon, union first of B. What is first of B? B epsilon. So B epsilon, include B, union, next nothing is there. Whenever nothing is there, then we have to take epsilon. Epsilon. It is like this. You can visualize this one in this way. We are computing first of A. Take all the elements of first of A. Take all the elements of first of A. Every element of first of A. Epsilon is there. Exclude this. Replace the position of A. Again compute. Union first of B. Take all the elements of first of B, B epsilon, include B, epsilon, replace, again compute, again first of S. What is first of S now? Epsilon is included. That's why the final result is A or B or epsilon. So the first of S is nothing but first of S is A or B or epsilon. So union of these things. So like this we can compute first of S. So whenever the production is this way, S gives AB, A gives A or epsilon, B gives A or epsilon. Then the first calculation of every non-terminal, first of S, A or B or epsilon, A comma B comma epsilon, first of A epsilon, first of B, this. So whenever epsilons are there, compute them properly. So that is the epsilon case is the somewhat carefully you have to compute, right? We have one more thing. This is one question asked one time in the GATE paper. If a grammar is like this, how to compute first information? What is first of S? From here A, from here B, from here epsilon. A, B, epsilon. What is from here? So first of S is nothing but first of S is A, B, epsilon. Then what is first of capital A? First of capital A. First of capital A is nothing but first of S. First of S is A, B. I will compute here. First of capital A is first of S. Take all the elements. Take all the elements from first of S except epsilon. All the elements means take include A comma B minus epsilon. And whenever you are excluding epsilon, replace in the place of S. So from here I am computing no. So replace here. Replace. Again calculate. Union. What is there here? Again first of A. Now first of A. This first of A, what it will produce? First of S in the sense first of epsilon. So first of epsilon is epsilon. So AB union epsilon. So here AB epsilon. AB epsilon. Similarly, first of B. What is first of B? Same thing. If we are unable to remember the formula every time, better utilize like this. Compute in this way. First of B is nothing but first of S. First of B is first of S. What is first of S? AB epsilon. Include AB, exclude epsilon. Exclude epsilon. And replace in the place of S. Replace epsilon at the place of S. Again compute. Union. What is first of B now? Epsilon. So epsilon also included. So this is the total result. First of S, AB epsilon. First of A, AB epsilon. First of B, AB epsilon. First of all this will be. So this is the way we can compute first set information. Now we'll focus on follow set. Follow set is important and little bit confusing, not much. It's very easy. What is follow? In any grammar production, assume we have a grammar production like this. we have a grammar production. What is follow here? Follow is nothing but in grammar, whenever a non-terminal is right side, whenever a non-terminal exists in the right side, its next terminal information is what? So follow of a non-terminal is nothing but set of terminals which appears right hand side part of that non-terminal. Set of terminals which appears right hand side part of that non-terminal. In the sentential forms, generally sentential forms are grammar productions. This is the follow information. That means a grammar symbol, next to what is there, right side next. That information also we are gathering, which is also required for our parsing techniques to design parsers. Right. So here let us, to compute follow, we have some rules. We need to understand the rules here. First rule is, whenever a starting symbol S is there, any grammar starting symbol, the starting symbol of follow of a starting symbol, any grammar, every grammar contains starting symbol. Follow of starting symbol always dollar, because dollar will be there at end of sentential forms. So that's why just remember this, follow of starting symbol we have to take dollar. That is first point. Follow of starting symbol is dollar. Follow calculation also we have to do from, follow calculation also we will calculate from by depending on grammar right hand side only. Grammar right hand side. Okay. There is a small difference between first and follow. Follow set does not include epsilon. Epsilons will not be included in the follow set. Epsilons will be included in the first set. We have seen already. Okay. Right. Next one, look at this. If any grammar production is like this, capital A gives alpha bx, capital A gives alpha bx, then how to compute follow of B, follow of B. So here follow of, two W's are not required. A gives alpha bx, then follow of B is nothing but, what is the follow of non-terminal? That non-terminal right side next. So this non-terminal right side next is what? X. So first of X, follow of B equal to first of X. Here X will not produce epsilon directly or indirectly. So whenever a non-terminal production is like this, alpha bx, follow of capital B is nothing but next one first. So first of follow of B equal to first of next symbol, first of X. X will not produce epsilon directly or indirectly. Next one, if the grammar production, third point, if the grammar production is A gives alpha B, A gives alpha B, and B is the last one here, nothing is there in the right side. In this case, follow of B is nothing but follow of capital E, left hand side. So follow of capital B is follow of capital E. Follow of capital B, follow of last symbol is nothing but follow of deriving symbol. This is our third one. Fourth one and second one almost same. Fourth one and second one. Here X not producing epsilon, here X produces epsilon. A gives alpha bx, and X is having epsilon. Whenever epsilons are there, epsilon case we have to compute carefully. Follow also same. Whenever epsilons are there, we have to compute them. So look at here. If grammar production is like this, A gives alpha bx, then we want follow of B. We want follow of B. What is follow of B? Follow of B is nothing but first of X minus epsilon. Follow of B is first of X. Next one first. Follow of B is nothing but first of X. But X contains epsilon here. X contain epsilon. Whenever X contain epsilon, then Take the first of x minus epsilon, exclude epsilon, replace in the place of x, replace in the position of x. Same thing, however, we did in the previous case, here also same. First of x, whenever x is produced a epsilon, replace here. Once again calculate fall of b. So what is fall of b now? Now b becomes last symbol, it becomes into rule 3. Now fall of b is nothing but fall of a. So union fall of a, union fall of a. So this is the way. So fourth rule is important. Fall of b is equal to first of x minus epsilon. If epsilon is there, take minus epsilon, replace here, replace here. Again, epsilons are there, very one fundamental rule is epsilon whenever we are getting in the result, replace them, again calculate, replace them, again calculate. Like this repeatedly we have to calculate if epsilon is there. So this is the way of computing follow set. So let us see calculation of follow set for some of the example grammars. If you know how to find first and follow set, so follow set also included first set. First information also required to compute follow. Okay, so let us see some of examples here how we can compute follow information for given grammar. Find follow set for given grammar. So I'm computing follow set for initially for some of the basic grammars. Then we'll see some of the gate level questions for which how to compute follow information. Here three productions are there. We need to compute follow set. What is fall of starting symbol? Fall of starting symbol is nothing but dollar. Fall of S is dollar. Fall of a starting symbol is dollar. Next one, fall of capital A. The starting symbol, this is the first rule. Already previously we have seen. First rule is fall of starting symbol is dollar. Whenever we have a starting symbol, for any starting symbol, follow calculation is nothing but dollar. Fall of starting symbol is dollar. Okay. Next assume we have capital A. Then what is fall of capital A? Whenever we are computing follow set from grammar right side, fall of capital A is nothing but next one first. So next one is B, first of B. What is first of B? B. First of capital B. So here I am writing the rule clearly. Fall of capital A is nothing but next one first. So first of capital B. So what is first of capital B? That is B. Right. Next one, fall of B. This is rule 3. Look at the rule 3. Fall of last one is nothing but fall of B is nothing but fall of A. Fall of A value take into the B. So here fall of capital B is nothing but fall of S. Fall of S. So what is fall of S? Fall of S is dollar. So fall of S value copy to this. This is the way. So fall of starting symbol is dollar. Fall of capital A is B. Fall of capital B is fall of S. So dollar. So like this. This is the way of calculation of follow set for basic grammar. But here epsilons are not included. I will calculate follow by including epsilon and some other variations also. So let us see one more example. Here we'll see how to compute follow. This is also one more basic one. Let us try to compute follow set information for this as well. So what is follow of starting symbol? Starting symbol S, it is not there anywhere in the right side. So follow of any starting symbol is dollar. Follow of starting symbol is dollar. Next, what is follow of capital A? Capital A is there here. Next one. Capital A is there here. Next one. So from here, A, from all positions you have to compute. Right side, how many places are there? From here, small a. From here, small b. So follow of capital A is nothing but A comma B. And similarly, follow of capital B. Follow of capital B is there. Next one first. That is B. Capital B is there here. Next one first. That is A. So like this. Follow of starting symbol is dollar. Follow of capital A comma B. Follow of capital B, B comma. Okay. Right. So let us see one question that is asked one time in GATE. This is the question asked in GATE paper. How to compute? First and follow both are given. First anyhow we have calculated for this as already. We are going for follow calculation of this one. Here S is starting symbol and which is already also available in the right side. It is a starting symbol which is also available in the right side. How to compute in these type of situations? S is a starting symbol. It is already present and also present in the right side. Starting symbol also present in right side. In that case, how to compute the follow set information? It's very easy. Anyhow, we will go in the same way. So what is follow of starting symbol? Follow of starting symbol is dollar, and from here follow of A union follow of A, and also there here from here follow of B union follow of. This is the all from all places. Because of starting symbol dollar is included. From here follow of A, and from here follow of B. So the follow of S is union of all these possibilities. Right. Next we'll go for follow of S. Follow of S is already there. Follow of A. So follow of A. What is follow of A from the grammar? Wherever capital A is there, mark those places. This is one place. This is one place. From here B. So next one first. It's capital A, next one. That is small b. It's first. B. From here capital A, next one first. Here A. So follow of capital A is nothing but B comma A. And see here. Follow of A, whatever is there, follow of A will be included here because this is union of all this. A comma B should be included. Right. Okay, next we will go for follow of capital B. Follow of capital B. So follow of capital B, follow of capital B is, where is the B in the grammar right side? B is the last symbol here. Whenever last symbol, so copy from S. Copy from S. Last symbol, same thing. So follow of B is nothing but follow of S. What is follow of S? Till now AB dollar or dollar AB, anything same. Dollar B or any order is anything inside, no? So AB dollar, right? Okay. And then, so whenever it is AB dollar, this AB dollar information will be included here also. So it is a union of all this, union of all this. So that's why fall of S is nothing but AB dollar, the overall result AB dollar, and fall of A is B comma A, fall of B is AB dollar. Okay, getting? So this is the question. This type of, here we are calculating repeatedly. See here, S value computing from B, S value computing from B, again B value computing from S. Like this recursively sometimes we need to compute. Whenever we need to compute recursively, then also it's anyhow same thing, concept is same. Here from S we have to take, here from B we have to take the result. So B value included in S value included in B, finally S and B value will be equal, both are equal. Dollar is included for starting symbol, dollar will be only for starting symbol. Okay, so these are first and follow values are some of the basic information like our ambiguity in yesterday's class ambiguity, which are required to apply parsing methods. Parsing methods, parsing algorithms designed by grammars only. So whenever you want to apply parsing methods, parsing algorithms, this calculations, this analysis is also required. Okay, so I will give you similar one variety of question. You can try as a homework. This is also one of the question. So star R here. You can take this as a homework. Try. So what is fall of L and fall of R? Calculate fall of L. Find how many elements are there and calculate fall of R. These two we can practice. How to compute fall of L. Here also we need to compute recursively. See here, fall of R value required for fall of L, fall of L value required for fall of R. L value will be copied to R value will be copied to L. So both final, like this recursively we need to compute here also. So try for this example. If you have any doubts regarding this, if you are facing any difficulty in the calculation of follow for this, you can ask me in the coming class. Okay. So that is about first and follows. If you have any doubts from your end, you can ask me now. Any doubts from your side, you can ask me. First and follow things are very much required. Okay. Okay, students. That's all about today's class. In today's class, we discussed about first set information calculation, follow set, how to find first set for a non-terminal, how to find follow set for a non-terminal. In the coming classes, we'll learn by using these basics of grammar, top-down parsers, bottom-up parsers, constructions. Okay. Thank you all. Bye-bye. See you in the next class.